This rock feels sandy. The texture is rough and kind of gritty, and if I rub it really hard with my thumb, then in between my fingers I can feel small little particles. And that's because this rock is sandstone. It's literally made from sand. Sedimentary rocks, like sandstone, are made from sediments, small particles of rock or other material that had been carried by wind or water. If you would like to make your own sedimentary rock, you can't do it just by pushing sand together. There has to be a cement that holds those grains together. In nature, that cementing material is usually a mineral like calcite, gypsum, or quartz, and it can take thousands or even millions of years for a sediment, like sand, to turn into a sedimentary rock, like Navajo sandstone. I'm Science Mom.
I'm Math Dad.
And today we're going to make our own sedimentary rocks, but we're not going to wait thousands of years for them to form. We're going to make ours in a matter of days.
Well, what are we going to use for the cement? Concrete?
Sugar.
Ooh, really?
Really. Sugar forms crystal structures just like the minerals that cement together other sedimentary rocks like sandstone. As long as you dry out each layer carefully, it will do a really good job.
So is this rock candy?
It is not rock candy because we're using sand as our sediment, and you do not want to eat sand. Hello! A quick shout out to Holden watching in Los Angeles, to Amaya watching in the UK. I see Lily Games and Servant Well and Izzy in the chat. Welcome, you guys, and a special welcome to you if you're watching the replay. Today, we are talking about sedimentary rocks, and I'm ready to show you the rocks that we made. Because if you take sediment, if you take small pieces of something and then put them together, that is, in essence, a sedimentary rock.
Did it actually work, though? That's the question.
We're about to find out. We're about to find out. All right, Math Dad. So here we have our first rock, and this is hard and sandy and gritty, and you can see layers. Here is darker sand, lighter sand, and then sand with sort of some rocks in it. But we also made some out of cornmeal because I thought, you know what? If we made it out of cornmeal, then it actually would be edible. Let's see if this one worked. This is a very thin layer of sediment. Is it like a rock? Did it dry enough? Just about. And it's dyed blue. Just for you, Math Dad.
Yeah, I love blue messes.
And then we did one that has several layers. We're going to tear it open right now, and this is the moment of truth. Did it work? And the answer is...
I don't think that stays together very well, Science Mom.
So with cornmeal, we didn't get quite as good sticking together as we did with our sand and our rocks. I also baked this one in the oven to make sure it was really dried out. But you can see layers.
Did you not bake
the cornmeal?
The color one? Yeah.
I did not bake the colored one.
Because
we ran out of time. This was like my last minute team feed Math Dad idea, where I thought, ooh, maybe he actually would like a rock he could eat. So I tried making one out of cornmeal, but you can see it's sort of falling apart. All
right, I'll try it.
You're going to try a piece of it?
Yep.
It's basically just cornmeal and sugar. How's it taste?
Like cornmeal and sugar.
All right.
It tastes better than sand would have tasted.
Yes, you do not want to eat sand. No. Now, this simple activity that I did, where I layered layers of sand and rock together and then poured over this corn syrup, really sticky solution, and then baked it and let it dry and did it again and again, I actually made a rock. But this rock would not be permanent. What would happen if I put this into a tub of water?
Are you saying the sugar would dissolve?
It would. The sugar would dissolve and the rock would come apart again. But if I take a true sedimentary rock, like this piece of sandstone, and I put it in water, is it going to dissolve?
No.
No, and that's because the sediments, the tiny little pieces, are cemented together with quartz.
Oh, so it's a stronger cement.
It's much stronger cement, much stronger cement. Let's do a quick introduction and look at some sedimentary rocks. But before we look at these 4 examples of rocks, let's talk just a little bit and remind ourselves about where sediments come from. So I have a picture right here of our family inside a little carved out hole at the Valley of Fire State Park. How did that hole get made?
Was it wind that created it?
Wind and erosion. So wind is probably one of the main forces, but water as well. And wind and water, that spot, probably the cement holding that sandstone rock together was a little bit weaker in that spot. And that spot, all of the sand got eroded away.
Or
Nobody went
did
with
it weather away?
It weathered away. Good catch, Math Dad. It weathered away, and no one was in there with a shovel hammering out that hole. It formed naturally, but then where did all the rock go?
It eroded away, and I assume gravity just washed it down.
Yeah, so it was washed down in stream beds and is going to end up somewhere else. And where it ends up, it's deposited, and those deposits, that's what forms future sedimentary rocks.
So that will end up getting compacted, and some type of quartz or glue
will hold it together, and it will make a rock. Yes. And here is a quick erosion mystery for you. So this is a picture of a hike in Death Valley National Park called Mosaic Canyon. And you can see that there is a handrail over there on the side. And our kids are climbing up the handrail, but the handrail literally goes nowhere. Like you can just walk around and then you see the handrail go up and stop. What is it doing? Why is there a handrail there?
So that's a good question. Why would there be a handrail that leads nowhere? Just so the kids can have fun?
It's not just so the kids can have fun. It's because of erosion. So this handrail, it used to be that the whole entire floor of that canyon was about 6 feet higher. And there was this steep part of the rock where it just went down and it was slick and it was hard to climb up. And so the Park Service about 100 years ago said, oh, I know, we'll put a handrail on the side so that people can climb up and over. But then every time it rains and a flash flood comes down the canyon, the floor of the canyon changes because sediments are carved out and they erode away.
Well, that's pretty cool. And so in 100 years, we're seeing a level drop of 6 feet. That kind of makes sense. That's a river, so you're going to, or a riverbed.
Yeah, a couple
sediment
times a year.
Can move quite a bit. The flash floods through those canyons can be pretty intense, but still, that's quite the change.
It's a big change. So sediments are being created and they're moving around all the time. Now we're going to meet 4 different types of sedimentary rocks. Our first one is called shale. I'm going to show you an actual piece of shale here, and then we're going to look at a picture. So this rock is gray and flat and a little bit flaky. And it's thin enough here that if I push hard, I can break it. And let's take a look at the picture we have of shale. I've got a photograph that shows you that this really forms in layers. And I'm curious in the chat if you have a guess about where shale comes from, what it was originally, put it in the chat. And quick shout out to Mary Fisher, who had an outstanding little joke that I saw in class in the chat before class started. Here you go, Math Dad.
All right, I'm ready.
Why are sedimentary rocks so cheap?
Why are sedimentary rocks so cheap? They're not expensive.
Because they're on shale.
Nice job, Mary.
Yep, that's a good one. So do you think it's from an ancient mud flat, an ancient coral reef, an ancient sand dune, or an ancient riverbed?
Mud flat. I mean, Noah's already saying it. Ancient mud flat. Huh?
Noah's got it. Mud flat is correct. And you can see in this picture here that there are layers to these mud flats. That for a while, a certain type of sediment was being dropped and then a different type came, and that changed the way that the rock was. Shale is the most common sedimentary rock in the world, and it is formed from ancient mud flats that were around millions of years ago, and it's a very common rock to find fossils in. Because if you have an animal like an ammonite, like a little snail with a shell, and it falls down into the mud and then gets buried, then it becomes part of the rock.
Way cool.
Yep, I'm seeing lots of mud flats in the chat. Good job, you guys. Our next rock is sandstone. So this is the piece that I held up in our little intro, and it really does feel a little bit rough. And if I rub it real hard with my thumb, and then I rub my fingers together, I can feel just the tiniest little pieces of sediment in between my fingers. So sandstone often has a pretty red color, but it can be a variety of colors. And the picture that you saw of us in that little hollowed out area, that was sandstone, and so is this. This is an arch in the Grand Escalante National Monument. All of that rock that you see is sandstone. Any guesses what this rock used to be when it was first laid down as sediment? What was it? A mudflat, a coral reef, a sand dune, or a riverbed?
Wow, it's so pretty and red. It's got to be a sand dune, right?
Yes, a lot of sandstone, not all sandstone, but a lot of sandstone is from ancient sand dunes. Large, huge masses of sand that then became compacted and turned into rock. All right, next one, Math Dad, is limestone. Limestone is used for a lot of different construction projects, and it's a common rock that's made into buildings, and it also has a really pretty either white or gray color. And if you drop a little bit of vinegar on it, it will fizz.
Oh, a chemical reaction?
Yes. So what is your guess? Where does limestone come from?
Is it caves?
It does not come from caves, but caves form in limestone. So limestone is used commonly in construction. This courthouse in Kansas was made out of limestone, and this cave is also made out of limestone. Caves form in limestone.
Was it the ancient coral reef?
It is ancient coral reefs. And a seashell, if you scratch a seashell and then put vinegar on it, it will fizz. It's made out of calcium carbonate. Limestone will do the same thing. And long ago, it was an ancient coral reef. Pretty amazing, right?
That is. The reef is huge then. There's a lot of limestone in the world.
There is. Our next couple of rocks come from somewhere kind of awesome. They come from West Virginia, courtesy of Science Mom Amber.
Oh.
And this sedimentary rock is flammable.
What?
You can light it on fire. Any guesses as to what this is, Math Dad?
I don't know. It almost looked like obsidian because it's black and shiny. But
it is black and shiny.
But obsidian is not a sedimentary rock. I don't know.
Are you serious?
Yeah.
You don't know what this is?
What is it? I'm stumped.
Look to the chat. Help him out, you guys. Matt Dad is not sure what this shiny, dark, black, combustible rock is from West Virginia.
Oh.
Those are all hints.
It's shale.
It is not shale.
No. It's coal.
It is coal.
There we
Good
go.
job. It is
combustible
coal.
rock. I got you. Look at that. That is cool. That is pretty cool.
So coal is a sedimentary rock. And
thank you, chat.
And here is a picture of a coal mine. The United States has the largest coal mines, largest coal deposits in the world. And depending on what material was put down, you can get different types of coal. Some are harder and shinier than others. Some burn hotter than others. And with coal, our sediment was not sand or silt or ancient coral reefs, the skeletons of those coral animals. Our sediment was something that had more carbon in it. So let's take a look real quick at our edible rock, which ended up being kind of crumbly. So this sediment is cornmeal, and then we dyed it with food coloring and pasted it together with sugar. If this was buried long enough to compact into a rock, what do you think it would form, Math Dad? Would we form sandstone, limestone, shale?
Oh, goodness. I have no idea what would cause one to be different than the other.
Well, it turns out if you have a lot of carbon in your sediment, then you end up forming coal. Yes.
Okay.
Or sometimes it might, depending on how much carbon there is, it might turn into natural gas or, fossil fuels. Those come from things that have carbon in them. So if you had a huge, huge deposit of cornmeal, in theory, yes, millions and millions of years from now, you might end up with some sort of combustible sedimentary rock.
Okay, that is way cool.
Kind of cool to think about, right?
Yeah.
Our last rock is actually my favorite sedimentary rock, and it has a really cool name. This is called Conglomerate. I'm going to show you this tiny little piece here, but then I'll show you some pictures that look even cooler. So this Conglomerate rock looks like it is a mushed up piece of gravel. There are lots of smaller rocks visible inside it. And here is a picture of a conglomerate rock from Death Valley National Park. And
so those are big.
They are big. There's my hand for scale. You can see that a lot of those pieces of rock that are inside this rock, they're almost boulder size. Do they still count as sediments if they're as big as my fist?
I guess they do.
They do. So a sediment is anything that is naturally occurring and can be moved by wind or water. And sand is usually what we think of with sediment, but a boulder can be sediment too. And this conglomerate rock is formed from an ancient riverbed. And it really is rock. I can't go and just pick one of these out.
Well, okay, I'll tell you, when we went on this hike, I was sure, oh, look, those rocks are stuck in mud. I'll go pull some out. No, I couldn't pull them out.
It's actually a rock. It's been cemented together.
Yeah.
So conglomerate, that there is my favorite type of sedimentary rock.
So the word conglomerations, gather a bunch of stuff together. Yeah, so conglomerate rock. I like that name.
We're going to do our Where in the World mystery now, and then we're going to look at the notes real quick because there are some words to unscramble.
Oh, yeah, and I couldn't figure one of them out before class, so I'm going to need some help.
Needs your help to unscramble these words about where sediments come from. So are you ready for our Where in the World mystery, Math Dad?
Bring it on.
All right, this is a national park. It's near the equator, and you can see rhinos, 500 different species of birds, wildebeest migrations, lions, leopards, and cheetahs too. Where in the world is this?
Okay, well, near the equator, I was going to say Kenya. So this seems like African wild animals. So it's got to be in Africa.
Yep, you're getting closer.
Not Kenya. Is it actually a national park that I would know the name of?
You should.
Oh, no. I'm going to need some help, chat. I was doing well on these for a little while. Okay, somewhere in Africa, I'm seeing. The
Great Rift Valley is a good guess. You know, the chat seems to be a little bit stumped as well. We're getting mostly we're getting mostly guesses. I will tell you, it is the Serengeti.
Oh.
So this is the little drawing that goes with it in our notes. The Serengeti is one of the first national parks in Africa, and it has an incredible assortment of wildlife. So tall giraffes and wildebeest, so many different types of animals, and it's a grassland with a lot of acacia trees. So really beautiful and semi-arid. Let's get to the notes next.
Okay.
Semi-arid area. That is our Where in the World mystery for today.
All right, so you had your instructions here we're on page 72 of the notes, which are how to make a sedimentary rock. And gather a bunch of sediment, compact it, and form new minerals to cement the sediment together.
That cementing step is really important. You would not get a sedimentary rock if you just push sand together. It has to be cemented with new minerals. But where do sediments come from? This sort of is like a review of what last week when we talked about weathering. We have some words here that are mixed up. And Matt, I bet you know the first one.
Okay.
DIWN.
This is wind.
That's right. Wind can break apart small pieces of rock and weather it down to form sand. So wind is a way that we get sediment. The next one is
water.
Water. That is right.
Okay. Waves.
Waves is really another form of water, but beaches and the waves on the shoreline, they do really powerful erosion, just carving out and weathering away rock and then carrying it elsewhere.
Okay. Then rivers.
Rivers is water as well. And then is this the next one, the one you were stumped on?
No, this one's ice.
That one's ice. You've got it.
Okay, and I think I figured it out actually, but I was gonna say forts. Forts are causing erosion. It didn't make any sense. But
forts do not cause erosion.
But I think it's frost.
Frost is correct. And all of these things create sediments. And then the sediments in turn can be made into so many different types of rock, depending on what the sediment is made of. Because sand, if you put it together, you end up with a sandstone. Clay, if you put it together, you end up with shale. And then calcium carbonate, the material that makes the skeletons of coral, that will give you limestone. And if you have a lot of carbon, you will end up with coal or natural gas or some other type of fossil fuel.
And all of the forces above create sediments.
They do. All right, Math Dad, it is time to see what you have learned. So go to itempool.com/sciencemom/live. If you are watching the replay, remember at science.mom, there is a link where you can participate in the polls as well. We want to wish a very happy birthday to AW. Happy birthday, AW. And Math Dad is pulling up our notes.
So which type of rock was your favorite, Science Mom?
My favorite is conglomerate. Do you have a favorite sedimentary rock, Math Dad?
Ooh. I say the conglomerate was fun. Sandstone is just so beautiful.
Sandstone is pretty neat. I want to also wish a very happy 12th birthday to Trey Feldman from Maryland. Happy birthday, Trey. We're back over to this view now.
I can do it.
You can do it, Math Dad.
All right, we are going live.
We're
the new
going
session.
live.
First question. Fossils are most often found in igneous rocks, metamorphic rocks, or sedimentary rocks?
You're going really easy on them for the first question, Math Dad.
I don't know. Maybe they'll get it. I don't know. I think I whooped on them last week, if I remember right. So got to go easy on them once in a while. All right, I've got 75 votes for one category. I'm not stumping very many with this one. All right, and I'm going to finish and reveal sedimentary rocks. So that's correct.
That is correct.
I guess that makes sense because of the way they're formed and they're laid down over time.
This is actually the only type of rock that you can get fossils in, because a living thing can be laid down with sediments and then cemented together, and minerals replace that living, what used to be a living thing. It becomes a fossil. But a metamorphic rock, and it depends on how much it's heated, a metamorphic rock undergoes so much heat and pressure, the minerals change. So fossils are usually destroyed. And an igneous rock, could you have a fossil survive being in lava?
Nope.
Nope.
Oh, that's really interesting. I just hadn't thought that it's the only type. But yeah. All right. Well done.
Which of the following are sediments? So select all that apply.
So boulder, gravel, sand, silt, clay. Wait. So what is silt?
Silt is a particle that is in between sand and clay. I feel like I'm getting run over by the bars, Math Dad.
Take that, Science Mom.
So clay are super small particles, and silt is in between sand or larger particles.
So these are all essentially just particles from largest to smallest.
But they're made out of different things. So sand is made out of silica, and clay usually has more magnesium and other elements inside it as well.
So it can break into smaller pieces more easily.
Yep.
All
right. All right. We're going to go ahead and finish and reveal so that
this is
Science Mom gets out of jail because I'm covered up with these bars. All of the above is correct. And I see that sand was the most common choice, followed by gravel. And it looks like clay was the least common choice, which surprises me. I thought it would be boulder. I thought a lot of people would think that boulders were not sediments.
That's what I was asking about. Yeah.
But anything that can be moved by wind or water is a sediment. And in a conglomerate rock, sometimes these pieces of gravel that are in this one, sometimes you get conglomerate rocks where they actually have large boulders that are cemented inside sand and other minerals.
All right. Question 3. If you leave a sedimentary rock in water for a year, it will turn to mud. True or false? Ooh. This one's going to get him.
I don't think so. Mariah says it took a looking back, and you haven't beat the unbeatable science kids in a long time. And they're not counting last time's calculus question because that was total trickery.
All right. Well, this is going to be the one. This question right here. It's going to stump them.
They're not looking very stumped, Math Dad.
Just because they picked one answer doesn't mean it's the right answer, Science Mom. All right. And they said false, that a sedimentary rock will not turn into mud.
That is correct. Because the cement that is holding together this rock is a lot stronger than sugar or Elmer's glue or any type of material that you and I would use to make a homemade rock. It is minerals that have totally bonded to those sediment pieces.
A lot of sedimentary rock would be down below rivers, lakes, and things. Definitely hasn't dissolved.
Yep.
All right. Which of the following is not a sedimentary rock? Coal, limestone, sandstone, shale, granite.
Which is not a sedimentary rock?
So don't select any that are
And we have
sedimentary rocks.
I saw a request for Science Puppy. Do you want to go grab Science Puppy real fast? And I will give just a small hint. There is one of these that is not a sedimentary rock. So see if you can discover which one it is, which one is not a sedimentary rock. And here he comes. Science Puppy.
All right. Wants to be here to watch me crush them in this final question.
No, I don't think they are.
All right.
Finish and reveal.
And granite.
Granite is correct. Granite is an igneous rock, and that is one of the common misconception. A lot of people don't realize granite is igneous. Nicely done.
Yeah,
Coal, limestone, sandstone, and shale are all sedimentary rocks.
You actually showed examples of those today. All right, our final question for the day. Ancient riverbeds form which type of sedimentary rock? Shale, limestone, conglomerate, or sandstone?
And I won't give any hints, although I'm tempted.
Oh, yeah. Science moms are always trying to give hints. They need a lot of hints.
What's your favorite sedimentary rock, Method?
Oh, I think you kind of asked that before, but I mean, the sandstone is so pretty.
Oh, that's right. You said sandstone.
Yeah. The conglomerate rock's kind of fun too, but yeah, hard to beat sandstone. Like you think it's made up. It's such a cool, beautiful rock. So
it is. Sometimes you can get really pretty striped patterns in sandstone as well.
Ooh, look at this science mom.
This one?
For sure, more people are doing the wrong answers than the right answer.
Ooh.
So this one counts as a victory, right?
We'll see. We'll see. It all depends on which answer gets the most votes. Let's finish and reveal.
All right. And conglomerate.
They got it right. My favorite type of rock is formed from ancient riverbeds. And the cool thing about conglomerate is by the size of the cobbles and how it changes over time, scientists can actually tell what direction the water was flowing, how fast the water was flowing, because the faster the water is, the bigger the pieces of sediment it can move. So you can learn a lot about how an ancient river worked by looking at the conglomerate rock.
Yeah, the sedimentary rocks are pretty cool. I think as a kid, I just thought, oh, those are the breakable ones. Those ones aren't as important, but they're actually really cool.
They are.
Some of the prettiest rocks you'll find, and also very prevalent.
Well, and super useful. The Great Pyramid of Giza was faced in limestone. They use that as the construction material, and so many of our modern buildings are made from limestone, sandstone, and other sedimentary rocks.
So several people in the chat said they got all the questions right. Nicely done.
And I'm seeing requests for the chicken worm, the orange justice. We will really quickly. We did not have time to film a new dance this weekend.
Did I not win?
We will do the chicken worm because that one's my favorite. All right, try a worm.
Ouch.
And then we have a fantastic question from Solar Eclipse about amethyst and opal. Are those sedimentary rocks? Are those igneous rocks? What are they? We are going to talk about gemstones a lot more this next week when we have our How to Identify a Rock lesson. So we'll do that more. But minerals are usually talked about in a separate category from rocks, although a rock can be a mineral and vice versa, depending on how you define rock.
That's a really good question.
That is a great question, Solar Eclipse. Nicely done. Harper says, you'll never beat us. Not counting super hard math questions.
You guys are going down next time. Next time.
We hope you enjoyed learning about sedimentary rocks. And if you do want to try to make your own sedimentary rock, I will tell you this requires quite a bit of patience. It's not something you can do in one day. It takes several days to dry out each layer. But as you explore sedimentary rocks, look for layers. Because just like we made this rock by putting a layer of sand and then a layer of more sand and more sand, almost all sedimentary rocks will have some sort of layering. That's a really common thing if you know how to look for it. All right. Work hard, grow smart, and we will see you on Wednesday.